Hello and welcome to another lesson. Today we're going to do a short lesson. We're going to go back and we're going to compare the states of matter. It's very important that you know this forever until the end of your lives, because it's extremely important to be able to distinguish between the properties of solids, liquids, and gases. Now, as you can see on screen, I put a table, and that table is extremely important that you know all of it. But we're going to go one by one through them. So I'm going to scroll down. All right, so now we have solids. So when we think of solids, we're going to always use water and its different states as an example because it's just easier. So when you think of solid water, we're thinking of ice. Now, what is ice? Or what's the structure of ice? So we know that a solid will always maintain its structure. That's why it's fixed. Its shape will also be fixed and its volume will be fixed. What does that mean? That means that it doesn't change. So if I have ice, obviously if it's cold enough, if I have ice, it will always retain that same shape unless, of course, I break it or change it, whatever, or raise the temperature. But other than that, a solid will always be a solid. It will always have the same structure, it will always have the same shape, and it will always occupy the same amount of space or the same volume. Think of your cell phones. Your cell phones, they're, as I said, they don't melt in your hands. They don't change shapes. They don't do anything. It's a cell phone. It's gonna stay the same, whether you look at it today or look at it 5 years from now. It's still gonna be the same cell phone. Okay, so how about compressibility? Now, solids, they don't have compressibility. We're going to say none. We're going to go for an all or none category, although they are a little extremely, little bit compressible. We're going to say that's negligible. So we're going to say solids do not have compressibility. Now, the attraction of the particles. The attraction of the particles is extremely high. Why? Because they need to stay together to have a fixed structure, a fixed shape, and a fixed volume. So it doesn't change shapes, volume, or structure again. All right, so I put an other category, and in this I wrote particles vibrate in place. Why? Because it's extremely important. Particles will always vibrate. It doesn't matter, or move. It doesn't matter if it's in a solid, liquid, or gas. Particles are always in constant motion, even though you can't really see it. If particles were to stop moving, we'd have a very bad problem. So if I were to draw the atomic or particle structure of a solid, let's say the sphere, that's a particle. So because the particles, the attraction of the particles is high, we're going to put another sphere. They're going to all be together, extremely tight. They're all really tight in there. All right, so I've drawn a square, or if you keep adding more spheres, you're gonna get a cube anyway. The point of this, they stay the same. They're not gonna move. However, they're gonna vibrate in place. So that's where I'm gonna put these quotation marks right there. All right, so that's solids. All right, now we're gonna talk about liquids. When we think of liquids, think of water, drinking water. Now, liquids, unlike solids, liquids do not have a fixed structure nor a fixed shape. These terms are interchangeable. What this means is that the liquid, if you see a liquid, you can't really pick it up. You can't pick it up with 2 fingers. You're gonna need your whole palm. So that means that the liquid will actually take the shape of its container. Now, its volume, however, this is important. Its volume is fixed. Liquids, they do have a fixed volume. However, they do not have a fixed structure nor shape. What does that mean? That means that if you take some liquid in a bowl, you can measure how much volume there is. If you put it in a graduated cylinder, for example, you know how much liquid you're going to have. However, it needs to be in a container because it does not have a fixed structure or shape. Now, liquids, they are not compressible, just like solids. You can't really push down on a liquid and make it be smaller. Like you just can't. It's a liquid. It's gonna flow out the sides. Now, the attraction to the particles, or the attraction of particles, is moderate. Why moderate? So liquids, they're kind of like an in-between between solids and gases. So solids have the most attraction between their particles. Liquids are moderate, while gases, they practically have no attraction between their particles. What's the advantage of having a moderate attraction of the particles for liquids? That means that the particles can actually flow past each other. That's why it makes a liquid be able to move like it does. So if I were to draw a liquid, that's going to draw these particles again. Remember, these are particles. And I'm not going to draw them as close together as I did the solid. So I'm just going to make it seem like we're in water. So they're the particles. And these particles, they're moving. They're moving not as fast as gases, but not as slow as solids. Now, that's what makes them able to flow past each other. So for gases. Now, moving on to gases. When we think of gases, always think of water vapor or steam. They do not have a fixed structure. They do not have a fixed shape, nor do they have a fixed volume. Gases, you can't really measure them unless you trap them inside some kind of container, and then you're going to be able to measure that container. But other than that, you're not going to be able to do anything more with gases. Why? Because the attraction to the particles is weak, extremely weak. That's why the particles move independently of each other at really, really, really high speeds. Alright, and they fill in a container, they are sealed in. Now, let's look at this right here, compressibility. Compressibility. Gases are extremely compressible. You can actually take a gas, seal it in some kind of container, and then you can actually push down on that container and you will be able to compress the gas. So first of all, before I demonstrate what compressibility is in a gas, I'm going to draw what a gas, or a diagram of what the gas particles would look like. So I'm drawing these particles like really far away from each other, and I'm going to do this. So imagine these little semi quotation marks. I'm sorry. They indicate motion. So here, they're moving like really fast, extremely fast, and they collide into each other, and they just keep going by about their day. They move at extremely high speeds. All right. Now, going back to compressibility. So I'm going to draw this down here. Let's say I have something like plunger, something. How about a syringe? So we're gonna try to draw this container right here, and I'm gonna put my finger. Imagine that's a finger. It's a really ugly finger, but whatever. You get the idea. So there we go. And I'm gonna write this here. So my gas particles are gonna be here inside, like moving like crazy. Again, they're still moving like crazy. I'm gonna draw 4. Now, if I were to push down on the top of that syringe, see, I'm pushing down. Let's draw it again. And there's the finger again. All right. So let me push it down a little bit further. So I'm going to push it down even further. Now, what happens here is that the particles are now actually closer together than in the previous drawing. So here in this drawing, those particles are really far apart. However, in this second drawing, the particles are actually closer together because we were able to compress the gas. And that's really all there is to it for solids, liquids, and gases. I'm going to put once again the table because everything's summarized right on that table. Remember, be able to reproduce that table from memory. Just learn it. It's really important. Have a good day.